Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. I would like you to make reference to this booklet here as we are going to look at the two factors that contributes to what makes temperature different from our booklet on Introduction to Climate. Okay, today we are going to move on to looking at two more factors, and they are to do mainly with distance from the sea. And you are going to find that as one of those factors discussed in our book, and as well as that we are going to look at cloud cover. So those two factors are what we are going to cover in our lesson today. Most of the part in the lesson, I would want you to be doing your note-taking or taking note on those two factors which contribute to what makes temperatures different from one place to another. Before we go ahead to looking at that information, we revised on what we have covered in our previous lesson. And in our last lesson, we looked at hotter by summer, colder by winter, or hotter in winter. Sorry, hotter in summer, colder in winter. And we also looked at altitude and how altitude has an impact on the temperature. Looking at hotter in summer and colder in winter, we said generally in summer the sun is directly overhead the different hemisphere, and as a result of that, if the sun is directly above in the northern hemisphere, it is summer in the northern hemisphere. The areas in the northern hemisphere therefore will have their hotter season. Meanwhile, it is opposite in the southern hemisphere, because if the sun is directly above in the northern hemisphere, then in the southern hemisphere it will be winter, and it is also colder at that time. 6 months later, the opposite will be said. It will now be summer perhaps in the southern hemisphere, winter in the northern hemisphere. Therefore, in the southern hemisphere, it would be hotter because it is summer compared to the northern hemisphere where it will be winter and therefore it will be colder. The other factor that we looked at also is that of altitude. And altitude is simply height. The higher up we go, temperatures tend to get colder. We found out that for every 1,000 meters that you rise, temperatures will decrease by 6.5 degrees Celsius. And a simple rule that we had to remember was simply as altitude increases, temperatures decrease. And the arrows there perhaps would be a simple way of showing the relationship between altitude and temperature. We also had a diagram giving us an example, and that diagram basically showed us at sea level if temperatures were 25 degrees, and we said that temperatures decrease for every 1,000 meters. By the time we reach about 6,000 meters, then what will happen is that temperatures would be about negative 14 degrees Celsius. How do we get to negative 14 degrees Celsius? We know for every 1,000 meters we decrease by 6.5, and we can do the calculations up to 6,000 meters where we have approximately negative 14 if the sea level temperature was 25 degrees Celsius. Okay, we had an activity to do, and that activity also gave you practice on looking at generally what happens with altitude or what happens when we go higher to temperature. And we only found out that temperatures do decrease definitely by about 6.5 for every 1,000 meters of rise. We had two questions that you were asked to complete for your homework, and let's look at the answers to those two questions now. From what we have already covered on hotter in summer and colder in winter, and also the higher up we go, temperatures decrease. Question number 3 reads, why is it warmer at one time of the year than another? And that should go with our work that we've done on hotter in summer, colder in winter. Anyone in the class with an answer to that question? This is your homework question you're supposed to have completed. Marian, your answer for question 3, please.
Because the Earth is tilted on its axis, one hemisphere receives more solar radiation than the other, so they receive different solar radiation.
Okay, very good. Because they receive different amounts of solar radiation due to the tilt of the Earth, that then contributes to why it is warmer at one time of the year compared to the other. And that should be our answer. Give yourself a tick if you have that. Let's move on to the next question you're supposed to have completed for homework also, and that is why it is colder at high altitudes but warmer at low altitudes. You have to explain why it is colder at high altitudes but warmer at low altitudes. Mason, your answer for that question, or your explanation for that question.
Because the air is thinner at high altitudes, contains little water vapor, no clouds are formed to trap heat, making it colder, while at the lower altitudes, it is the reverse.
Okay, if we have that, very good. Don't forget, if we say no clouds, it might not be very true, but mainly we're looking at dust particles, water vapor at that particular level higher up. There is little water vapor, dust particles, therefore the air escapes quickly. Sorry, not the air, the heat escapes quickly, resulting in the higher altitude being colder or cooler compared to at the lower altitude. And that's one reason that you could have. What could be another possible reason we can have to explain why it is colder at high altitudes but warmer at low altitudes? What have we learned about the relationship perhaps between altitude and temperatures? Val.
The air is thinner at high altitudes than it is at lower altitudes.
Okay, definitely correct to say the air is thinner up in the higher altitudes than at the lower altitude. That would be the another reason why it is colder at higher altitudes but warmer at low altitudes. What could also be another possible reason? Gideon. The two answers given so far are definitely correct.
Because the higher we go up, the much colder it becomes.
Okay, and that could be the third possible reason also, which is correct, that the higher up we go, the colder it gets. And that is why it is colder at the higher altitudes, but warmer at the low altitude. And that is what we have learned so far. So all those three answers that were given are all definitely correct. Okay, we move on now to what I'd like us to cover today. And today, perhaps we can say the point will be, or not the point, but the factor will be factor 5 and factor 6, of which they are factors which contributes to what makes temperatures different from one place to another. So far, we have looked at hotter in summer, colder in winter. We have looked at altitude. The higher up we go, the colder it gets. We have looked at hotter by day, cooler by night, and we have also looked at latitude. The further away we go from the equator, the cooler or the colder it gets. Today we will move on to looking at factor 5 and 6, and for factor 5 and 6, distance from the sea and how that has an influence on temperature, and also cloud cover and how cloud cover has an influence on temperature. Let's look at distance from the sea first, and we can have perhaps another heading same to distance from the sea as hotter and colder away from the sea. The information now presented on our monitor. An important fact we must remember when we look at distance from the sea, and that is because the land surfaces, they heat up and cool down much more faster than the water surfaces. The further one moves inland, away from the sea, the less effect the sea has on temperatures. Remember this. Water heats up slower and cools down slower. Land heats up faster and cools down faster. Okay, remembering that important information, it will also help us to understand distance from the sea and temperature, how they are related or how one affects the other. Okay, I'll repeat again. Land heats up quicker and it also cools down quicker. The sea heats up slower, and it also cools down slowly or slower. Write that down somewhere. Perhaps it will help you. Okay, now we come to looking at the relationship between temperatures and the distance from the sea. And the information tells us that because the land surfaces heat up and cool down much more faster than the water surfaces, the further one moves inland away from the sea, the less effect the sea has on temperatures. Does that make sense? Does it make sense? Okay, it's supposed to be if we understand that basic rule that I have mentioned. Land heats up quicker and it loses heat quickly also. Meanwhile, the sea or the water heats up slowly or slower and it loses its heat slowly also. Okay, we move on. Distance from the sea is mainly common outside of the tropics. You can really see the difference out of the tropics, which means in the temperate latitudes, the distance from the sea can be greatly seen to see the relationship between temperatures and that factor. Because the sea is actually slow in heating up and cooling down, the air over the islands and coastal areas remains much the same by day and by night, and also in summer and in winter. I'll repeat that statement. Because the sea is slow in heating up and cooling down, the air over the islands and the coastal areas remains much the same by day and by night, and also in summer and in winter. Okay, perhaps some of you are making note of that statement, so I'll give you at least a minute or so to quickly copy that down, and we'll move on. Okay, you've made note of that statement? Okay, we move on. Therefore, the further one goes inland from the sea, the hotter the summers tend to be and the colder the winters. I mentioned at the start, telling you that distance from the sea is greatly or can be greatly seen in the temperate regions. In the tropics, we do experience that, but it is not greatly seen as compared to in the temperate regions whereby they have the seasons, especially summer and winter. Therefore, with that statement, the further one goes inland from the sea, the hotter the summers tend to be and the colder the winters. Okay, perhaps if we have to understand that a little bit better, let's make reference now to our booklet, and let's look at the statement that is actually given in our booklet. Factor F from our booklet tells us about distance from the sea. Let's make reference to that information, and I'll read through while you follow. The sun's heat is absorbed and released more slowly by water than land. This is more noticeable outside the tropics in the winter season when sea air is much warmer than the land air. Hence, onshore winds bring warmth to coastal regions. In the summer season, land surfaces are warmer than sea surfaces, and the air over the land is therefore warmer than that over the sea. Therefore, coastal regions are cooler than inland regions. Climates whose temperatures are influenced greatly by the sea they are called oceanic or maritime climates. And climates whose temperatures are greatly influenced by distance from the sea are called continental climates. So with that information, we can also look at the other factors that can contribute to what makes an area closer to the sea hotter compared to those away from the sea. Perhaps let's take, for example, if we are going to look at an area whereby there is a warm ocean current. The warm ocean current can have an influence on the area which are closer to the sea during winter. Therefore, that warm ocean current will make those areas which are closer to the sea warmer compared to a same area which is perhaps further inland and not influenced by the warm ocean current. We take 53 degrees latitude north. If we were maybe looking at a place in England, a warm current might influence the temperature of that particular area because it's closer to the sea. The warm current contributes to bringing warmth over the land, resulting in the temperatures of that area, 52 degrees north, to be warmer compared to perhaps if we go to inland Siberia, 52 degrees. There are no warm ocean currents there or no water. Therefore, the temperature of the same area, 52 degrees latitude inland, would be colder, even though it is winter, compared to the 52 degrees in England, and it is still in winter, but because of the influence from the sea, the temperatures might be warmer. So you see the relationship in terms of distance from the sea and the further away we go from the sea and temperature can have an impact on the temperatures of that particular area. So when we go back to our statement here, the further one goes inland from the sea, the hotter the summers tend to be and the colder the winters tend to be. I was looking at an example of in winter. In winter, 53 degrees, if an area is closer to the sea, the ocean currents may contribute to warming up that area. Meanwhile, the area further inland, it's winter, but because there is no influence from the ocean, the temperatures inland in winter would be much more colder than that of the area closer to the sea. Both of them are on the same latitude, 53 degrees north, but one is colder than the other because one is closer to the sea, influence from the sea, the warm current is warming it up. One is further away from the sea, no influence from the ocean currents, therefore it is colder. Okay, in summer, it might be a different story again because the distance from the sea may also contribute to variation of temperatures in summer. So in summer and winter, we have different temperatures due to the effect of the distance a place is from the sea. Let's look at a diagram here, perhaps to help us understand that also. We have the land, we have the sea. Incoming solar radiation as shown by the red arrow. This is a midsummer temperature condition in a temperate latitude. So it's summer in this particular diagram here. Note, we already learned that the sea heats up slower and loses heat slower also. The land heats up faster and loses heat faster. So it's summer. If it is going to be summer, the land is going to actually absorb the heat. It will heat up quickly. Okay? The sea is going to actually heat up or get to absorb the heat and heat up slower because of the fact that we know already about the water and land. Okay, this area here gets to warm up quicker. It is 10 degrees Celsius. On the sea, the area gets to warm up slower. It is, on the land, it is 15 degrees Celsius. It is warmer. On the sea, it is 10 degrees Celsius. It is cooler in comparison to the land. This is summer we are looking at here. The land heating up quicker, 15 degrees. The sea heating up slower, 10 degrees. Let's move on. This line here represents generally the coastal region. The coastal region, therefore, is going to be affected simply because of the cool air which is going to be blown during the summer months from the sea towards the land. So therefore, in this region here, as shown by the lines, the coastal region, this particular area, the air around it is actually cooled by the cool sea air coming in. Okay, we look at that same diagram. This time it is mid-winter. Look at winter. The sea loses its heat slower than the land. Therefore, over the sea, because it loses its heat slower, the temperature is 5 degrees Celsius. It is now mid-winter in that same area. On the land loses its heat rapidly. Therefore, on land, it is 0 degrees Celsius. It's colder here compared to here. This time, the warm winds blowing from the sea towards the land will bring the warm air to heating up that coastal region. You're following? So the temperatures here would actually be warmed as a result of the warm winds blowing from the sea towards the land during the mid-winter temperature conditions. The sea heats up slower. More heat is actually kept here. That heat, therefore, is used then to warming up the coastal region. Therefore, the temperature of the area, the coastal region here, would be warmer in mid-winter. Any questions with regard to that? Okay, I'm going to give you time, perhaps, to make note of that diagram. The first diagram here showing us midwinter. Digest the information there, perhaps, and it might help you understand a little bit more better on distance from the sea and how distance from the sea has an impact on temperature. 5 minutes, is it plenty of time for that first diagram? Okay, I'll give you 5 minutes, and then later we'll move to the second diagram for you to make note of. got a diagram there. Okay, everyone made note of the diagram? We'll look at the next diagram, this time showing us the mid-winter temperature conditions. Same area, only that there is a difference now because of the seasons. So this time, the second diagram represents the mid-winter temperature conditions in a temperate latitude. What do you have next? What do you have this period? Okay, have you made note of that information? Okay, I'd like us now to look at what we have read from our booklet again, and perhaps from the, with the diagram, and what we would have read from our booklet should make sense. So let's look at our booklet again. Distance from the sea, looking at what you have constructed or what you have copied down into your exercise book. The sun's heat is absorbed and released more slowly by water than land. That is a basic fact that we must remember. This is more noticeable outside the tropics in the winter season, when sea air is much warmer than land air. Why is it that the sea air in winter is hotter or warmer than the land air? Why? Ovio.
It is because it loses heat slowly.
Okay, very good. That's because the sea air loses its heat slower compared to the air over the land. Therefore, the sea air is much warmer in winter compared to the land air. Hence, onshore winds, therefore, will bring warmth to the coastal region. We understand that. So therefore, winds will bring that warmth from the sea during winter to the land, resulting in the coastal region during winter warmer compared to the places inland. In summer, or in the summer season, land surfaces are warmer than the sea surfaces, and therefore the air over the land is warmer than that over the sea. Again, I could ask the same question. Why is it in summer that the land is warmer than the sea? Silo, why?
Can you repeat the question?
The question again. Because the statement reads, in the summer season, the land surfaces are warmer than the sea surfaces. The question is, why is it in summer that the land surfaces are warmer than the sea surfaces?
Because the land absorbs heat quickly.
Okay, good. The land absorbs the heat quicker and it warms up quicker than the sea. Therefore, the air over the land is warmer than that over the sea. And the statement reads, in summer, the coastal regions are cooler than the inland regions. Do we understand that? Okay, and that will also go with our work on distance from the sea. Remember, the work that we are looking at is mainly looking at the temperate regions outside of the tropics, because distance from the sea and temperature is more marked in the temperate regions. It occurs in the tropics also. You will find that generally if you live around where the coastal regions are, by day and by night, there is also variation in temperatures. If you are someone who lives right where the shorelines are or along the coastal region, during the day, you will find that the coastal area during the day will be much warmer or cooler. It will be cooler because the land at the tropical regions, especially I'm making reference to now, will heat up. And when it is heating up, the air rises. Upon rising, the air from the sea will move in to take the place of the rising air, the cool air coming in. During the night, the sea will heat up and lose its heat slower than the land. During the night, the land will be much more cooler than the sea. Therefore, the sea air will rise because it's warmer. The winds then will blow from the land towards the sea. We understand that. Okay, this is within the tropics, perhaps. We can experience that the day and night difference in temperatures because of the distance from the sea. But we are looking at mainly a bigger distance from the sea and the temperate regions because of the fact that there is more land there. We'll have a good example to explain to us the relationship between distance from the sea and temperature. Any questions with regard to that information. Questions? Okay, if there are no questions, and because of the fact that we have also run out of time, I wanted us to look at cloud cover, but we will not do that in our lesson today. We'll do that in our next lesson. For your homework, what I'd like you to do is to see if you can make note with the information that we've got on distance from the sea, and perhaps with the notes, you can take that from your booklet with factor F, and it might help you understand a little bit better on what we have covered from distance from the sea. With that, that will also bring us to the end of our lesson. Class, if you can stand up now. Okay, to the pilot teachers, our keyword for lesson 106 is maritime climates. Good afternoon, and thank you, students.